Have no fear, our FCPX Fabric tutorial is here. FCPX Fabric is an innovative plugin that lets you create amazing fabric graphics that you can customize with your own brand, like a flag. It's an impressive plugin, and it can be used by beginners and experts alike. The plugin contains several pre-made presets for you to use. And don't forget to check out the amazing cloth transitions also included. In this tutorial, we'll be focusing on the default fabric tool. For more information about the advanced tool that includes additional controls for editing the texture map, visit our tutorial linked in the description below. Let's get started. First, at the top, let's check out the instructions. Select the button to open the instructions window. It will appear in the center of the screen. Each page in the instructions will contain information about what each control does. At the bottom of the window, use these previous and next controls to switch pages. When you're finished looking at the instructions, select the X to close out the window. Now let's see these controls in action. Let's start with the media controls. Drop zone lets us apply our new media to the flag. We'll add our logo, for example. Looking snazzy. With pan, we can adjust the position of the media horizontally or vertically. But be careful, because the media can eventually fall off the flag if we go too far. Scale adjusts the size of the media. Now, if we select this triangle to expand the drop zone controls, we'll see many more options. Texture. X position adjusts the horizontal position of the drop zone. Y position adjusts the vertical position of the drop zone. Rotation X rotates the drop zone along the X axis. Rotation Y rotates the drop zone along the Y axis. Rotation Z rotates the drop zone along the Z axis. X scale adjusts the width of the drop zone. You can go as far with this as you want. Y scale controls the height of the drop zone. Now we can select the triangle again to hide these controls. Image Scale Offset is a minor depth texture size control, which helps to eliminate edge artifacts that may occur. It's a pretty subtle difference. Next, let's look at the materials controls. Texture selection allows us to select a different texture for the cloth for the 30 textures provided. Let's expand the texture controls. These work the same way as the ones we saw for the drop zone, but they apply to the texture instead. So here's a brief demonstration of how they affect the texture. Try out the other options as well, and have fun with it. Now let's move on. Toggle Wireframe Only, if checked on, hides the fabric texture to let us see just the wireframe of the graphic. This is useful to turn on when using some of the advanced tools. Visit our tutorial linked in the description below. Depth controls how much the texture will protrude from the flag. If we lower the depth, the flag will be more smooth. Roughness changes the texture of the flag, which adjusts the way the light interacts with the fabric. At the moment, we can't see too much of a difference, so we'll come back to it after we look at metalness. Metalness adjusts how the material of the flag will interact with the light. The more metalness added, the shinier the flag will be. And if we go back to roughness, it will react to max metalness. Now let's scroll down to see more controls. Down here, we'll see transform controls for the flag graphic. These work the same way as all of our transform tools usually work. So check out our separate transform controls tutorial to learn more. Next, let's look at the fabric animation controls. Note this update simulation button here. Every time we make a change to the fabric controls, we'll need to select update simulation to refresh the results. If the viewer doesn't immediately update, try adjusting the playhead position. Or try tweaking another control. And it should update. To save time, from now on, we'll cut out the parts when we update the simulation. Next, with the starting rotation controls, we can adjust the orientation of the flag at the start of the simulation. Starting rotation X adjusts the rotation along the X axis. Let's check how that looks. Starting rotation Y controls the rotation along the Y axis. Now let's compare the results. Starting rotation Z determines the rotation along the Z axis. Let's take a look. Next, we can adjust the mesh, which affects how many vertices can be used in the simulation. We'll switch on toggle wireframe only so it's a bit clearer. Now we can see the specific points that are manipulated by the wind, gravity, or other settings in the simulation. Mesh row count adjusts the number of vertices per row. Mesh column count adjusts how many vertices there are per column. Let's see it in action. Notice on the right, the additional vertices react to the physics differently. Now let's turn the wireframe back off, and we'll move on to the next control. Anchored edge determines where the anchor of the flag will be. So at the moment, we have it along the left side, but we can also choose to have it attached to the corners only. Or even have no anchor. If there's no anchor, be aware that the flag may just fly away or fall down, depending on your other fabric settings. So we're seeing a blank screen, but if we back up our playhead, we'll see the beginning of the simulation. So that's where it went. Now let's check out both results. Here's the simulation with left corners attached and with no anchor. Fabric weight dictates how heavy or thick the fabric is, which changes the way gravity and wind affect it. Here's what that looks like. Fabric shear determines how stretchy the fabric is. The higher the value, the less stretchy it is. Let's see how it looks with this change. How interesting. Fabric bend adjusts how bendy the fabric is. The higher the value, the less bendy it is. Now let's compare. Fabric delta adjusts the snapback force of the fabric. The higher the value, the lower the force of the fabric as it animates. Let's see how that looks. Adjustment to this control are pretty subtle. Fabric dampening adjusts the velocity resistance of the fabric, so we'll increase the noise turbulence first, which increases the wind activity. Now, if we increase the fabric dampening value, let's see how much the fabric resists the additional noise turbulence. Let's check it out. On the right, the flag is affected more evenly by the noise. Gravity amount determines the amount of force applied to the fabric. And here's how that looks. Look at the downward force applied to the flag on the right. Noise turbulence adjusts the amount of random variations in the wind. Let's check the result. Look at it go. Wind turbulence determines the level of rapid fluctuations in the wind's velocity. Let's see the difference. Pretty neat. Wind velocity x controls the speed of the wind along the x-axis. If we take it to 0, there won't be any horizontal wind velocity at all. Or if we take the value to 20, notice how much stronger the horizontal wind is. Wind velocity y adjusts the speed of the wind along the y-axis. Let's see it in action. Look at that flag blowing upward. Wind velocity z determines the speed of the wind along the z-axis. Here's how it looks. Now the flag blows towards us. Now let's take a look at the sine wind controls. Sine wind creates an oscillating wind effect. You can think of it as a wind effect that ripples the fabric itself without affecting the path of the entire flag. By default, it oscillates wind on the z-axis. Be sure to select this triangle to expand the controls if they're hidden. Sine amount determines the intensity of the sine wind effect. If we increase the amount, notice a difference. So ripply. Sine speed determines the velocity of the sine wind. Here's a better look at that. With the next 3 controls, we can also rotate the sine wind direction. Before doing so, we'll increase the sine amount to max. First, let's rotate it along the x-axis. This will add a vertical ripple to the fabric. We can also rotate the sine wind along the y-axis. Let's check it out. This creates more horizontal wind activity across the fabric. Next, let's rotate the sine wind along the z-axis. Let's see the comparison. Now the fabric has a much more pronounced rippling. Now we'll uncheck it. And we'll scroll down to see the rest of these controls. Frames sets the number of frames that the fabric animation will last. So if we set it to 200, for example, and factor in that the fabric starting frame is -50, our simulation will end in about 150 frames, which in this 60 frames per second project is under 3 seconds. Inverse time steps determines the frames per second to calculate the simulation at. A smaller value will speed up the simulation, and a larger one will slow it down. It makes a big difference. Reverse animation flips the animation backwards. Fabric's starting frame determines which frame in the project the simulation will begin at. For example, starting the frame at -50 means that the simulation has gone through 50 frames of animation by the time our first frame begins playing. On the other hand, if we changed it to +50, our flag would start out all stiff. Then the simulation would begin after 50 frames. Cool, right? Random seed randomizes the wind turbulence directions, as well as the wind's noise. We can use the sliders to select a different randomized value. Let's see a comparison. What a difference! Toggle self-collision allows the flag to collide with itself, which changes the result. We'll notice a few subtle differences. Collision distance works with self-collision and determines the radius per 100 pixels for cloth vertices to calculate spherical collisions with. It also prevents clipping. Here's a comparison. Interesting effect. Moving on, we'll hide the fabric controls. Now let's scroll down again so that we can see the remaining controls in this preset. Let's take a look at the camera controls. These affect our camera view of the flag. For a deeper dive into these controls, check out our tutorial in the description below. Now, we'll skip to the new ones. Focal length adjusts the angle of view of the camera. This affects how much space our subject will take up. Near plane sets the distance where the camera begins to see objects. Far plane sets the distance where the camera ceases to see objects. The differences will be more significant if the other parameters have greater adjustments. Depth of field applies blur to objects outside the range of focus. Now let's check out the depth of field controls. We'll reveal the controls by selecting this triangle. Focus distance is the distance from the camera in which the flag is completely focused. If we change the focus distance, our flag may go out of focus. In this case, 2 happens to be the sweet spot for the current settings. Sensor height is the vertical size of the camera's viewing angle. Be careful not to increase it too much, as your flag may go out of focus. F-stop number determines the size of the camera lens area. If we decrease it, naturally the flag will go out of focus. We'll keep it there to demonstrate the next control. Number of aperture blades is the number of blades that the camera uses in the lens, which affects the blur shape in some cases. Focal blur sample count is the number of points that the blur effect will sample. Increasing this will increase the quality of the depth of field blur at the cost of speed. Next, let's adjust the lighting controls. Lighting type lets us choose a lighting scheme from the light setups listed. Here's what our flag looks like when lighting from above. To turn the lighting off altogether, choose the None option. Pretty wild. Lighting color lets us use the color picker to adjust the color of our light setup. Ambient light is a secondary source of light that creates uniform lighting on the overall scene. Here's how it looks when turned off. Ambient light intensity determines how bright the ambient light will be. Wow, what a difference! Ambient light color lets us choose a color for the ambient light. And those are all the controls for the preset. Don't forget that you can customize your flag with other objects as well. For example, we can add a flagpole image and a sky background. Here's an example of that. Your mind has been blown.